Hey, hello, welcome everyone back to the Hypernode Developer Preview podcast, I guess. Well, we have some new things to show this time around. We have some people here. We have Timon, we have Alex. Alex is the lead developer of the Hypernode Systems team, and he's going to show us a bit about our upcoming product, dedicated databases and database replicators and things like that. But first, we're going to talk a bit about the Hypernode-Docker environment. So this sprint, we've made some changes to the Docker environment, and mainly we are going to update Varnish to Varnish 6 in the default images if the PHP version is higher than 7.4, because that's going to be useful for new Magento installations. So in case if you guys haven't seen it yet, there is a repository. It's called Hypernode-Docker. It's on GitHub. You can just look at it. And it has a bunch of links that you can pull. So these are just images that you can pull and you can run them. And so what is this? This is basically a container image of the Hypernode environment, but in a container image. So we just run our configuration management on Docker. We basically package that as kind of like a fat container, and you can run this locally. So if you would do that, would look something like this. So you can just actually run this image. And it's going to start up all these services like you would have on a normal, regular Hypernode. So it's not the same thing because it's actually a container and not a virtual machine, but it's close enough. So it has all our versions of packages, configurations, and everything. So it can be really convenient to use this in testing or CI or whatever, just to see if it's going to work in the Hypernode environment. Because what you never want is that once you ship to production, you find out something is kind of different. So with this, you could test some things out locally. So it's very convenient. You can just log in to this container locally, and then you get your trusted Hypernode environment. So this is just a Hypernode as you know it. It has all the things. So unlike on production, you can actually be root here and do some things configuration-wise that you cannot do in production, but it might be convenient for debugging. So like you would expect, everything is here, and but the services run in screens. So they are like background processes. You can attach them like this. So in this case, what I wanted to show was the Varnish version. So now you'll see we're going to be running Varnish 6 now instead of Varnish 4, which is an upgrade and also a requirement now for the newer versions of Magento. So Timon, maybe you want to tell me something about your experiences with using the Docker image when you were building web shops using Hypernode.
Yeah, well, I have some experience building web shops indeed, and I've also had some experiences using Hypernode-Docker. So when I was building web shops, we were using Hypernode-Docker to create test environments on a test server, to review feature branches that we made. So yeah, that's what we used that for back then. Currently, there are more technologies available like Hypernode Brancher, or you could even do something like a Warden configuration on a test server and make that publicly available to your customers. So there are different options now, but it's really nice if you run into some problems that are very Hypernode specific, and you want to make sure that that you can reproduce it on a Hypernode. Or it's really nice to have this available in your toolkit, and we still support this. So
we have many different images, different versions that you can use. So it's not like on a Hypernode where you actually want to be switching the versions inside the machine. You just want to run a different image. And of course, you can also combine this with different Docker images as well. So maybe you have like a Docker Compose development environment locally, and you want to test out what if I run it with exactly the software packages that run on Hypernode. This could be a very convenient thing. So we sometimes use this as well for testing, and we have many people who use Hypernode who use this as well. So it's kind of an alternative to having a dev environment in the cloud. Sometimes you just want to run things locally, and this can help you do that.
Yeah, exactly. I think it's very important to recognize the fact that this is used specifically to like get to know the Hypernode tooling specifically. Like Timon said, right? You have Warden, you have these kinds of things. Like we've specifically made Brancher to solve the development process specifically, but Hypernode-Docker is like a very low barrier to entry kind of way of like introducing you to the different concepts that we use around Hypernode. Like Hypernode managed VOs, this is a typical thing that you could use in a Hypernode Docker situation where you can just figure things out, try it locally for once, and see how it works.
Yeah. So as you can see here, I'm actually using the kernel of my host system because this is a container. So yeah, like I said, things will be slightly different than the actual production environment. But it's also very interesting to be able to run this on like different hardware. So maybe you're doing some crazy things, then this could be very, very handy. Okay, so I guess that's enough about Hypernode-Docker for now. Let's talk about the next topic, which is actually super interesting. So yeah, Alex, how about you start us off on the databases?
Yeah, great. Okay, so I kind of got a spoiler in the background, but so one of the things that we've been talking about for a couple of years now is the ability to have, instead of one single VPS, which is the Hypernode at this point, which carries all of the functionality of your stack, the PHP, Nginx, MySQL, those kinds of things. Those are typically all built in one place, very much like the Hypernode-Docker. We've wanted for a very long time to extract this kind of functionality to a different server, right? For multiple purposes. It's, well, for one, it's to like distribute the load of the database, which is typically very memory and IO intensive, to a separate server, which can properly deal with the situation. So if you find the bottleneck to be on your IO or your memory, it's a very logical thing to start extrapolating your MySQL responsibilities to a different server. So you still have your Hypernode, except that we extract it to a different place. And then the second thing would be, because of that, is because we're already experienced in like having how do you say that? Like a separate instance to do just one thing. We can easily add on top of that another instance which does another thing, right? So you can have a replicator server to make sure that your data is safe. It's stored on a different server. So if something goes down or something gets corrupted or whatever, we've seen all kinds of circumstances that it's on a separate server that is not affected. So we can automatically fail over. If something were to happen, we can fail over to the separate server, which would be a third one, so that you can have like redundant availability of your MySQL instance.
Yeah, so to showcase this, we've prepared three scenarios. One is the traditional Hypernode, as we all know it, the single node model. So everything is locally running on this machine. So I have my Magento installation here, and yeah, as you can see, I got PHP, Nginx, functional SQL, everything. So that has some benefits for performance because there's no latency, there's no network overhead or anything. You can just directly talk to these servers in the same machine. So in case of Magento, historically it's been like this, where every request does a lot of queries to the database. So uncached requests do like many queries for individual pages, and then that's solved with caching and layers on top to reduce all of this. So once you start offloading the database to a separate machine, then you have to take the hit on the latency between these queries. But it really depends on your shop if that's a big deal or not. So it can very well be the case that you want to scale out to a degree where this overhead is warranted. So it makes sense to say, now I just need more compute, more CPU, more disk speed or whatever, put it somewhere else, so that then the latency is not my bottleneck, but actually the total scale of the compute that I can manifest is. So we have these three things prepared. We have a normal Hypernode, we have a Hypernode with a separate database, and we have a Hypernode with a separate database, but also a replicator. And we'll go over those and yeah, just show those and talk about them for a bit. So
yeah. And also just to clarify, like there's still a very valid use case to have like just a single instance, right? Because There's less complexity. If you have your caching not set up in like a proper way and you always are talking to the database, it's best to just keep it on the same instance, right? It gets you reduced latency. I mean, you still need to travel to the other server if you really want to, but if you have, the regular things set up, like a Redis instance to cache requests coming in, those kinds of things, it's very logical to start adding a database to your, I don't want to say the name cluster, but to your cluster of servers.
Yeah. So yeah, it's really a trade-off depending on your use case. We really want to highlight how important it is to have a good oversight of your web shop. I think the biggest problem we have with we see from customers is that they want to know what's going on, and then the more moving parts you add to your system, the harder that becomes. So even though at a certain point you might need to scale with just more than one machine, you also have to remember that these days in the cloud, machines can get very big. So of course there is like redundancy trade-offs that you can make, where like maybe multiple machines with multiple points of failure is better than having one single point of failure. But then again, in the cloud, like there is a lot of redundancy that happens on that level, where there is network storage that can be remounted on different machines. The clouds can do live migrations to a different hypervisor if the physical machine breaks. But with dedicated servers, it's of course a whole different story. So you want to make sure for yourself where you want to make this trade-off. And it's a very valid option to say, I just want to have a separate database to offload that load for performance. But then again, it all has upsides and downsides. But we've had a very big demand from people who do want to have exactly this case. So we have 3 sample shops here. They're all the same sample shop with sample data and everything, but running on these 3 different configurations. So this one is a simple case where it's just one Hypernode. Let's see, this is it. So just a lay of the land here. We have a Magento installation. We have a list of vhosts, and we have a database. So if I would do this, show databases, I have my sample shop database right here, and it's just on disk right here. So one machine, all the services, and it's just there. So if you look at the next case, it's almost.
You can also show the host name in the MySQL REPL.
Yeah, what was the thing again?
It's like a select add host name, I think.
Right. Yeah. Okay.
Yeah, exactly. So that makes it very clear that we're talking to the same server instead of like a different server.
Yeah, exactly. So this is my host, and then this is my host name of the database. So this is proof that this database is actually running on this machine.
Yeah.
And if I would look at data web Magento app and PP, wait, let's see, and okay, so we can see here that this is actually the host configured in the database. So this is the host name, and then if you look at the hosts file, then you can see that the same host name is on the local host. So yeah, it's local database. We have the next server, which is the exact same shop, but on a different machine with a different configuration. This one actually has a dedicated database. So I'm not saying dedicated as in dedicated machine, but it has a separate machine, which in this case is a cloud node, which is the database. And we can immediately see something new here, which is this. So Alex, maybe you want to explain what this is all about?
Yeah. So I mean, this is like a nice little tool that we call the Hypernode cluster map. It's also available as a CLI command within your Hypernode. And in red, it shows you like where you are at the moment. So it's like if you're in a theme park and you've lost your way, you go to the local map. And then here we show you, here you are within your cluster. And if you want to go towards the next slideshow, you follow the arrow towards where you want to be. So
yeah, so you can also draw it like this. But anyway, so this is super convenient because we've had cases, at different hosters and other places where we're like, okay, so this is a cluster, but what exactly is in the cluster? Where am I in the cluster on the machine related to the other machines, and what are the roles of those things in the cluster? And we just wanted to make it super clear, where you can just see very quickly where you are in the cluster. So we're going to show the more complicated example in a bit, and then you can see why this is so cool. But like this color thing, it shows you, okay, I'm right here on this machine right now. And there is a relationship to a different machine, which is the MySQL database for this machine. So instead of running the database on this machine, it's now running here. So let's look at that, because I can still just type MySQL. So we have some Hypernode magic going on here in the background, where now we've configured things in a way where everything is just connected as you would still expect. So you can still run myprocs and do all these things. But now we're actually talking to the other database. So if I do host name, you can now see that this is not the same host name as the machine I'm currently running on. So this is the different server. So I can actually log into the server as well. This is where the database is actually running. So you can see here currently I'm now on that other machine. And yeah, so this has the database.
Yeah, so I think a couple of cool things to show is the etc host file, just to clarify how we're doing this. Okay, so this is the database. So the MySQL master record is still pointing to localhost, but in the case of the original Hypernode, the DNS record now points to the different server. So instead of this being localhost, you're actually highlighting the wrong thing. But
oh shit! Okay, sorry. Okay.
That's okay. It's okay. But the important thing about this is that we configure this. What we also do in the background is that we automatically whitelist any connections between these two nodes. We make sure that you are able to communicate through SSH between these two servers. We add a bunch of levels of monitoring on top of this, which we track internally. So if we notice that the connection between the two servers is degraded, we can automatically take action, right? So if your database starts acting up in a regular Hypernode, we automatically take action in the thing that we call the rescue process. Now we have similar things in place, but then for the cluster variant of this. So we automatically track it, and we get notified if something is up between the two servers.
Yeah, so let's take a look at the most complex case now, the actual one, the replicator. Because then we have 3 nodes in a cluster, let's say. Logging into the machine. Here we go. So as you can see now we don't have 2, but you have 3. So normally you would only have 1. We just saw the case where you have 2. You have just the normal Hypernode and the database. And now we actually have a 3rd server, which is the replicator. So what does the replicator do? It allows you to fail over. As in, if this one blows up, then everything that was written to this one is going to be available on this one. And then we can promote this to be the new master. And then it will just allow you to have this level of redundancy that you didn't have with only one database. And yeah, I can also show you the SSH thing, because Alex mentioned that you can log into these machines from those machines. So let's see if I can SSH. Okay, so I can SSH as app to the database on the normal Hypernode using the key in etc Hypernode SSH.
.ssh.
Oh, yeah, right. Yep. And then there's a list of keys here. And I'm going to use the hntest Hypernode to be 0. Yeah. So now we made the hop from that first server. I'm going to do it again to make it a bit more clear. So go here. Then we have the red highlighted here. Then we log again to the next server. Now you can see we actually made it very clear that you went from this one to this one. So you're now on this machine. And so we can go further into the network to the replicator. And it's going to be like this. Here we go. So now you can see very clearly where you are in this whole thing. So yeah.
So maybe it's nice to highlight the reason why we do this, because like for one, it's very helpful to be able to hop between the servers within your cluster. But most importantly, we want you to be able to easily access all of the relevant logs from whatever place in the cluster that you are. So one of the things that we've experienced in the past is we have some projects running that also use things like Kubernetes. And while these things are great, they tend to be very complex, and getting the relevant information from all of the right places turned out to be very difficult. So we want you to have an experience of dealing with clusters that's very convenient. So whenever you go to any node within your cluster and you want to debug some kind of situation, so let's say something is wrong with Nginx. So you want to figure out, okay, what's happening with my Nginx server? Just show me all of the logs coming into all of the Nginx servers, which is obviously not running on your MySQL server because that's just running MySQL. So what you can do is we've introduced a new tool. It's called Hypernode-Tail, related to the tail command. And well, as Rick is showing here, you can do
Shall
like
I run it? I guess so, right? Oh, wait,
Yeah,
different syntax. What is the syntax? I just need roles and then the file name.
You've got to specify -- file.
All right. Right. Required follow. Yeah. Okay. Here we go. So I broke the mic conf, but that's great because now we can see it. So this is now actually tailing the logs of all of these servers. So you can target it by role. So these machines have different roles. So in this case, we're talking about MySQL. So there's a MySQL role. Now I can just say, show me all the logs in real time, tail the logs of all these machines in this cluster. So yeah, that's very convenient because you want to be able to tell what's going on not one of those machines, but all of those machines. So this is a very simple example, but in the future, this definitely will become very convenient. Yeah, so we think this is a very handy thing to have. And yeah, and should we also show the replication process? You can actually see it running, right?
Yeah, sure. So there's a separate user. It's the MySQL replicator user. This is running on the failover server, and it's targeting like the main database. So we've enabled bin log streaming between the two servers so that they're in sync with each other, so that if something happens to the main database, we can automatically fail over and switch up like the main database role. So then you can see like in the cluster map, you can see that the replicator takes over the main database role and now continues on with as little downtime as possible. So even if something like shit hits the fan, something breaks, this process is very quick and data is safe on the failover server. And that's because of this replicator user.
Yeah. Shall I fix the MyCNF real quick so we can actually see it?
Yeah, sure.
I broke the MyCNF. Let me just take this over to here. And then I just update this and we're good to go. Okay. Okay, here we go. So you can actually see it receiving all this data. And so what I can do, for example, is create database test database. So I'm now on the primary server. And if I go to the secondary server, show databases. There we go, test database. So it's actually synced it from the one server to the next server, so that if that other server blows up, then we still have one that actually has everything that you wrote to the other one in it.
Yeah, exactly. So some other relevant information could be retrieved if you go to the. So this is the replica, right?
Yeah.
If you enter a MySQL REPL and you just type show replica status and then -G.
Is the underscore status? Show replica status?
Oh, it's without the dot comma. Without the semicolon, yeah. Is it show slave status then?
Hey, there we go. Okay.
And then, okay, interesting.
I'm running MySQL 5.7 here. This is MySQL 5.7.
Oh, okay. That makes sense.
MySQL yeah.
There's a bunch of changes in terminology here. So, so what you can see here is like it shows you that both the IO and the SQL threads are running. You can also see the bin log position. There's a bunch of stuff that we use here for monitoring. So we can also see like the replication lag between the two servers. And this is something that we are very strict in, that we also alert on. And if we see that something's going wrong between the connection from the failover to the main database, then we start doing the failover. Because then we determine if something is wrong with either the failover or the main database, and then we fix the correct solution. So.
Yeah, and this also gives you some flexibility. So if I look at the normal Hypernode in this thing, so if you look at the map again, then what if you want to scale a part of your application? So maybe you only need more CPU for BSP FVM, and then you can upgrade this one but you don't need to upgrade all of these. So you could individually, we call it X-grade, so that the X stands for up or down, but you can up or downgrade this plan to whatever size you need. And then you could do the same with the databases.
Yeah, exactly. So you could, in theory, also add more failover databases if you want to be really sure. Technically, that shouldn't really be necessary, but you could do that. Because this allows the option for you to start scaling horizontally more in a way than vertically. But even then, all of these 3 servers, those are still vertically scalable as well. They can separately X-grade, as Rick just mentioned. So that's still awesome.
Yeah. So I guess this is the things we wanted to show you this time. Alex, was there more that you...
There's one more thing that I wanted to discuss, and that's the differences between replica servers and failover servers. This is something that we're still discussing, I think. There's namely the fact that we can either attach a separate database instance to be acting as a failover server, or we can attach a separate instance that acts as a replica server. So it's just there, it's replicating data, and you can use it to offload the load on the database server, the primary, and use it as a secondary server to manage your reads and writes to that server instead. So that instead of just dumping all of the load in your main database, you can use that as well. We're still hesitating if we want to make that a feature, because that's adding complexity to the cluster overall. But I guess let us know if you want more, right?
But it depends on the use case as well. So if you're looking to shard your database, there's things you can do. But if you're looking to split your reads writes, there's some things you can do. I think this is a great start for offloading a part of your busy node to a separate place. And depending on your needs, we can make all kinds of things happen.
Yeah, you can also apply this to decrease your risk of running on a dedicated node, right?
Yep.
So, so if something dramatically fails on a dedicated server, you could, for example, say, well, to prevent that, we have a dedicated or a separate MySQL server, which is running on cloud. So whatever happens to that dedicated server, we still keep our data. So you can also play with that in that regard.
Yeah, and if you're looking for performance, there is a trade-off to be made in network storage versus local storage. So we have dedicated Hypernodes with local NVMe, which is super fast for I/O and latency for writes and all these things. But it does mean that it's a local disk. So the risk factor for that is a bit higher than a cloud disk from which we can live migrate to a different machine. But then again, if you then have a replicator thing, then the risk is dampened. So you get the best of both worlds, where you can have sick performance, but also still have a second line of defense if your physical machine has an issue of some kind. And you can play with this. Maybe you want to put your FVM node on a physical dedicated server, but then the database on a cloud plan to have that data secured in the redundancy of the cloud and everything. Okay, then I guess we're through our points for this time. I guess we'll see you guys next time with the next cool features we are going to talk about. So thanks again for listening. And Alex, is there something you want to ask of the viewers? If they want to press a button somewhere, maybe.
Oh boy, maybe you should like and subscribe and hit the bell notification button. Right?
Okay, great.
Okay.
Okay, well, see you guys next time.
All right, see you guys.
See ya.